All right, ladies and gents, let's talk about how galaxies evolve. When and how were they actually formed, and how do they change over time? When we look back in history and we look back in further away in space, we see further away in time. And about 10 billion years ago since the universe is about 13.7 billion years old, somewhere around when the universe was about 4 billion years old, we see the very first galaxies. And those first galaxies are these small ellipticals. Small ellipticals, they are more white because of the fact that that one actually has some spiralness to it. But these small ellipticals are very white. They're full of hot, bright stars. And when we look at these and we actually analyze the elements that made them up, they contain lots of hydrogen, helium, and very little else. Well, when the universe was first created in the Big Bang, the first two elements that dominated the entire universe for many, many, many years were hydrogen and helium. And as we've talked about in the past, stars have to go through a whole life cycle before you get other elements. So these very first small elliptical galaxies were about 10 billion years old, hot, bright stars. If we were going to look for a new Earth, if we decided we wanted to find a place like home, you're not going to find it around these old ellipticals because of the fact there would be no iron, no calcium, no magnesium, and these heavy elements that make up you and I. And so that's not the place to find life or anything that looks like a new Earth. These were very primordial old galaxies. What we believe happened was this. From these original small galaxies, they combined to form spirals and barred spirals. And as these galaxies came together, each one had some original velocity, they had some angular momentum, and that combined motion, when they collided, gave rise to the spirals and the barred spirals. Now, we believe at the center of every galaxy is a black hole. And over time, what would occur is these small galaxies with small black holes would then combine to form spiral galaxies. And what would occur after that is that those spiral galaxies would then combine, making larger and larger and larger black holes at the center. We now believe that black holes are essential for the formation of galaxies and the evolution of the universe. Generation or two ago, black holes were just something out of science fiction that astronomers suspected were there, but now we have so much evidence that they exist, observational evidence that they're all over the place. We now believe that they are an essential part of the evolution of the universe. It is also hypothesized that the size of a galaxy is directly related to the size of the black hole at its galactic center. If you have a huge black hole at the galactic center, that will support a very large galaxy. And in our Milky Way, Sagittarius A is our black hole. It is big, very big, millions of solar masses, but not as large as some others. After there were spiral galaxies, these spiral galaxies then would combine, and then they would combine, lots and lots of spirals would combine to form ellipticals, large ellipticals. Large ellipticals that contained a lot of old stars. These are ellipticals that look more like this. And one of the ways that we know this is when you look out into space, astronomers can see spiral galaxies that are in the process of combining, just coming near each other. And then after they have been colliding, you can kind of see a galaxy here and a galaxy there that are in that process of combining. The Milky Way it is predicted our Milky Way galaxy is going to collide with Andromeda in some point in the future, billions of years from now. When that occurs, this is one of the most wacky things that I think is hard for me to even get in my psyche. And because there is so much distance between individual stars that when these two galaxies combine, odds are that no two stars are going to collide. That you can actually have two galaxies move through each other and combine and they will never actually collide one star with another star because of the massive distances involved. Do you remember one of the first labs we did when we were talking about scale models? And if our sun was the size of a small ball, smaller than a basketball, the next star would be about the size of a tennis ball located in Vermont or Colorado. So there's a lot of distance between stars. So kind of summarize in one picture, small elliptical galaxies in the beginning. These combined and black holes existed at their center. And one of the things that's still being debated right now is, where did the first black holes come from? Were they from these small ellipticals, or did the black holes come before those small ellipticals? And that is still under debate as of the time I'm making this video. These small spirals, small spiral galaxies, then combined to form larger galaxies. And when these black holes would combine, they'd emit something called a quasar. We'll talk about quasars in this chapter. Those spiral galaxies would then merge, producing larger galaxies. And these spirals would then merge, creating normal ellipticals. So when we talk about ellipticals, mostly we're referring to the big, large, humongous ellipticals that we see today. But this is a really nice illustration of that process. One more time, two different kinds of ellipticals. The young ones, 10 billion years or older, young hot stars, and we suspect those were the first galaxies. Today, when we refer to ellipticals, many, many, many large, very large, reddish-orangey kind of ellipticals, indicating that they are colder stars, cold and old and hot and young, I guess, is the two different kinds of stars and galaxies we've got. And it is suspected that the future of all galaxies is to end up in one of these large elliptical galaxies. Sometimes people ask the question, what happens to the black holes? They're still there. The supermassive black holes are still at the center of those galaxies, but there is so much dust and there's so much matter in these huge, old, large galaxies that you don't see them. There's not as much evidence like the amount of evidence we see in spirals. All right, that will finish that bit. We're going to next time talk a little bit about quasars and active galactic nuclei. See you then.